Right, so last video, I'm just going to do one on just drawing the two different types of polymers. So first one I'm going to focus on is addition, and if you've got an addition polymer, you are starting with your alkene. So your alkene is going to be the monomer. We've looked at reactions of alkenes, and we've seen that when they react, it's always the carbons of the C double bond that end up in the reaction. And we've also seen that when they react, you lose the double bond. Now, if I try to do this as it's drawn at the moment, which I'm going to do it up here, if I just get rid of the double bond like I've done previously and put in my H's, we know to make this a polymer, we need to have extended bond lines. And hopefully when we get rid of the double bond, we should be able to see that it's the two carbons that are highlighted in yellow that need to have the extended bond lines. All right, so it's common convention to have it going from the left and from the right. But if you do that, you don't have your bond line coming from the correct carbon. So what I do instead is I do this. Now I've got a line coming from both of the carbons involved in the C double bond C, and that would be correct as a polymer. However, that looks pretty ugly, and you're never going to see something that looks like that on the mark scheme. So what's more common, because this group here, this CH3 group, is essentially in the way, we want the bond line to go out to the right, we just move that CH3 down to the bottom. So I'm going to redraw this again. I'm going to get rid of my double bond. So I've got CC, I've got my H, I've got my H, I've got my H. And then instead of drawing that CH3 to the right, I'm just going to move that CH3 down to the bottom. And to save space, I'm just going to write it CH3 and not show the individual bonds. Now I've got my alkene carbons in the correct place. It's much easier now to draw something that actually looks like a polymer. Extended bond line to the left, extended bond line to the right. Then I just put in my brackets, put in my N, and I've drawn myself a polymer. This will get you the mark, okay? It will, it just looks a bit ugly. And if they ask you to draw 2 repeat units instead of 1, that becomes harder with this representation. So if they ask me to draw 2 repeat units, I just have to draw this again, all right, exactly the same thing again. But if you're trying to draw this again, your polymer would need to come down here, and it all gets a bit messy. So I really would advise you to just move the group out of the way, and then have your extended bond lines coming from the 2 carbons that were originally part of the double bond. Other thing that they could potentially ask you to do is they could give you the polymer and they can ask you to draw it as a monomer. They can also ask you how many repeat units they've drawn. So this is a polymer. I know it's a polymer because I've got my extended bond lines and my brackets and my N. And if they're asking me for repeat units, it's just really simple. I just count my 2 carbons and that's where I would break it. So I've got 1, 2, 3 repeat units. To draw the monomer, I can take any of those units and just draw 2 carbons, so just 1, 2. I've got my Cl, I've got my H, I've got my H, I've got my H. And to make this a monomer again, I do not draw extended bond lines, and I put the double bond back in. Okay, so you have to put the double bond back in to make this a monomer. So I'm just getting back to my normal alkene. You can see here that I've gone CLH, CLH, and then that says HCl. And if you took this section to draw your monomer, you're going to end up with something that looks like this. So I put my double bond back in, HCl, H and H. Okay, and at first glance that might look different because I've got the Cl on the left, whereas on the bottom it's on the right. But if you took that molecule and just flipped it over, they are exactly the same. So it doesn't matter which one of these repeating units you take, even if it looks slightly different on paper, you have drawn exactly the same alkene. You've drawn the same monomer. Your other type of polymer is condensation polymerization, and for condensation you're going to have 2 different monomers. So previously we just had 1 monomer, an alkene, join them all up together. Now I've got 2 different monomers, but for it to be a polymer I'd need loads of these. So that letter N just represents a number, and you could have 100 or you could have 1,000. So 1,000 of these and 1,000 of these, and you join them all together in a big long chain. You're obviously not going to draw out 1,000, you only need to draw it once. And with condensation, as the name suggests, you are going to lose a molecule of water. And what's important here is where you're going to get that water from. So you've got an alcohol functional group. Alcohols lose H. This is also an alcohol, it loses a H. But where you've got a carboxylic acid, you're losing an OH. Alright, just think of it as the carboxylic acid is the more complex functional group. It's got more to lose. So it loses the OH, the alcohol just loses the H. And then to draw this as a polymer, I just draw exactly what I've got above, but leaving out what I've highlighted in yellow. So I'm not going to draw that H, but I am going to draw the O. Next up, I've got a CH2 and a CH2. Then I get to an O, I draw that, don't draw the H, don't draw the H, don't draw the O. Next up is a C double bond O. Then I've got a C with a H and a H. Then I've got a C double bond O. And then I don't draw the OH. And to make this a polymer, I'm going to have a long line coming this way and a long line coming that way. And that is my polymer. So as I said, you might have 100 of these and 100 of these, but you're just going to draw it once. This is your repeating unit. And then this would just repeat over and over and over and over again. Now, you are losing water, so you would need to show that. H2O. In order for this to be truly balanced, although they often don't require this at GCSE, it should be 2N minus 1 H2O. So if I had, say, for example, 200 of my alcohols and 200 of my carboxylic acid, then I would form 2 times 200 minus 1, 399 molecules of water by adding all of those alcohols and carboxylic acids together. The other thing of note here is that when you add these guys together, if we look at our addition polymer, we saw that there was only carbon atoms in the main chain, whereas here I've got carbon and oxygen atoms in the main chain. We've also got this functional group here called an ester. So we say that the polymer is joined together by an ester linkage. So the ester functional groups links the polymer together. And for that reason, we can call these guys polyesters. So poly just means many, you've got many ester linkages holding the polymer together. Down below, I've drawn a polymer. You could be asked how many repeat units. So you can see I've got C double bond O, C double bond O, O, CH2O, and then it just repeats again. Like this is all just exactly the same. So I would say I have 2 repeat units. And if they ask you to draw the monomers, find your ester linkages and break them. So my ester linkage is when I had a C double bond O, a single bond O. There's an ester linkage, C double bond O, single bond O. There's an ester linkage, C double bond O, single bond O. There's an ester linkage, C double bond O, single bond O. So what I'm going to be doing each time I have my ester linkage is I'm going to be breaking the CO bond. All right, that bond is going to break. That bond is going to break. That bond is going to break. And then I can draw out my little fragments. So if I break that bond, I'm left with a C double bond O, C double bond O. If I then have this fragment, it's an OCH2 going to an O. If I look at this fragment, C double bond O, C double bond O, and then my final fragment is OCH2O. Now, because I had 2 repeat units, you can see that I've just drawn the same thing twice. I don't need to do it twice, all right? I would just need to do it once. So I'm just going to rub this out. I don't need that. I mean, it's not wrong, but you don't need to draw it twice. And these are the fragments that I'm left with. Now, to get back to the monomer, all right, if we look at where we started, we lost H2O. To form this polymer, you're going to have to put H2O back in to go back to the monomers. So something is going to get an OH and something is going to get an H. Now, if I give these guys OHs, I get back to a functional group that I know. I get back to carboxylic acid. So that's what I'm going to do. I'm going to give each of those an OH, get back to the carboxylic acid. If they're getting the OH, then on the O, I'm just going to put a H, and that takes me back to the alcohol. So break your ester linkage, where you've got the C double bond O, add an OH back again. That takes you back to the carboxylic acid. Where you've got just the O, you add the H to take you back to the alcohol. So it's essentially a reverse of this process. Here you're losing water. To get back to the monomer, you're adding water again. Yeah, that's it.